Welcome back to Incremental, the Continuous Improvement Podcast. My name is Uriel Eisen.
And I'm Devin Bedoni.
And this is our practice edition where we talk about improvements from the week and tie them back to lean principles.
Indeed. And our quote, predicting rain doesn't count. Building an ark does. Warren Buffett. I do like this one.
It's kind of funny. I mean, to me, it's just sort of like, having ideas doesn't really count. Like, it's about reducing them to practice.
Yeah.
And with lean improvements, I feel like that's definitely part of it. Is like, you're not going to save time if you don't try things.
Yeah, I think also in the machinist community, like, or at least the part of it that I engage with, there's a lot of like, this would be amazing and this is how you should do it, and like, oh, this is the coolest idea. If you do this and this and this and this, it'll just be like so slick. Guilty. I'm guilty as well.
Yeah.
And then at the end of the day, it's like, it's all just a waste of time unless you actually implement those things, which is so much work.
Yeah. I've seen that around automation. I feel like a ton of people talk all sorts of stuff about automation, and it's like, then you try it and it's like, man, this is pretty simple. Like, it drops apart.
Automation part.
Like, and as we've talked about, like, there's stages of automation, and so going after like the first two stages is pretty easy. The last stage is really hard, and even the second stage is a little hard.
Well, the automation part itself is relatively easy, and like everybody says this as well, but it's all of the systems that encompass that surround it that are really the challenge. It's like, I don't know, the number of articles I've read now of just being like, they got a pallet pool and bumped their production by 400%. And you're like, cool. Sounds amazing. First, you have to be able to program that many parts.
Yeah, that's a good point. But again, it's sort of like, there's all this talk about how cool it would be to automate. And it's like, well, maybe just do it and see.
Yeah.
And it's a big step, but
no, I agree. You should absolutely just do it. And that also includes like just learning how to program that many parts and just ponying up and buying like 60 vises.
Yeah.
Like, oh God.
Yeah, for sure.
Ouch.
Yeah, I also like it. It makes me chuckle coming from Warren Buffett, because I feel like in the financial markets, there's sort of a lot of talk about like, this person predicted X event like 5 year, they've been right every time.
Oh yeah.
And it's like, well, then why didn't they invest on that? Like, if they're so sure about their predictions.
Some of them probably did.
But, and they're not the ones you're reading about, because they're just sitting at home being pleased with their stacks of cash. Yeah. Anyway, improvements from the week.
Yeah. Should we go over our 8 wastes first?
Oh yeah.
Overproduction, overprocessing, excess inventory, defects, transportation, wasted motion, waiting, wasted human potential. I wonder if you can like judge sort of like the phase of a business by where most of their waste lies. I wonder if there's themes.
I mean, you could. Interesting.
Probably it's like early phase, waste is everywhere. Late phase, their waste is only in a couple spots.
The thing is, it wouldn't be stages of a company in terms of size. It would be in terms of like lean, because there's huge companies that are massively not lean.
Oh yeah, no, I meant in terms of their process.
Yeah. I find I sort of move around between them of what I'm noticing week to week. I don't know, but they are great. It's such a useful tool to have that like at your fingertips, because as I mentioned, we've been starting to do A3. Yeah. And it's been really awesome in a funny way. We were looking at our assembly table, and the issue is it's like not good enough. And it's sort of like, well, what does that mean? And so we tried to quantify it, and I'm not sure that this is correct, but we decided, because A3, like the first step is quantifying your current state in measurable terms that are measured in numbers, and like no sort of subjective ideas of like, we need to improve this. This isn't good enough. This is hard to use.
Qualitative.
It's like, so it's like quantitative measurements. So we decided we wanted to aim for 288 square inches of free space. And then the second we said that, we walked over to the table and started measuring things. And we're like, oh, like we have one of those small computers laying flat on a desk that is like hugely prized territory. It like literally never gets interacted with. And it's 8x8. So that's 64 of those square inches we're seeking. And it's sort of, it just makes it very approachable.
Like directs you sort of.
Yeah. And I feel like similarly, knowing the 8 lean wastes or whatever wastes you want to look for in your shop, it just makes something really like specific enough that it's noticeable. I don't know, like if you go around looking for weighting, for examples of weighting, you'll find a whole bunch that you sort of never noticed before. And if you walk around looking for like overproduction, similarly, I don't know, it helps notice, or for me anyway, it's been helpful to have them to try to look at processes and go, what are the wastes we see here? So
should I jump in?
Yeah.
We have been on sort of a big push this last week of getting all this new work holding up and functional. So pretty much everything here has to do with that.
Okay.
But like I mentioned last week, we were working on these trunnion tables, and actually getting them operational was quite a bit of work.
Yeah.
So luckily, Quorum is pretty good with like just kind of like general fab and like figuring stuff out. So he did a fair amount of the work. So the first thing was he made when I first had added pneumatic vise and gripper to our one S700 machine, I'd made kind of a quick mount for the valves and regulators.
Yep.
Didn't have any more room on it. So he made a new one that is a much better layout and has room for, and he pre-drilled for potentially having 8 valve regulator combos.
Nice.
And it's pretty compact. Got that mounted up and then added one for the vise that we just added. But it should really streamline adding on a flip station with a gripper and any other pneumatics that we need to have as part of the system.
That's cool.
So I was pretty excited about that. And man, getting those things dialed in was a lot more work than we anticipated in terms of tramming them in to be flat and square.
Because?
Still not totally sure. So one of them went really smooth and the other one was a bit of a challenge and it's not perfect. The suspicion is that, so what was happening, trying to figure out how to explain this to somebody who's not familiar, but basically it's a table. If you imagine like a dinner table and standing at one end and then grabbing it and like rotating it around your waist, or not like spinning, but like rotating it, like flipping it upside down.
Yeah.
That's what this is doing. So the trick is to get the pivot on the far end concentric with the pivot at the rotary.
Yeah.
And to ideally make sure that the table that spans between those 2 points is perfectly in line with that axis of rotation. So our suspicion was that the rotary maybe wasn't perfectly trammed in initially. Okay. So it was essentially
like angled up or something,
angled to one side. So we would tram it in on one side. And then when you go to the other, it would be totally off because it was describing a cone sort of.
Gotcha. Yeah.
And then also possibly the two, like the junction between the end plates, the vertical portions and the table were not perfectly square.
Okay.
We're being pretty picky here. Like to a non-machinist listener, we're talking about like over that distance, half the width of a human hair out over like 20 inches. So it's like, we're being pretty picky, but kind of wanted to take the time to get it right since ideally we'll never be taking it off and it'll reduce wear quite a bit. If it's more or less perfect.
Right. Wear in the bearings, is that what you're worried about?
Yeah, just all of it. And just unpredictability, being able to transition work holding from one machine to the next potentially without, and know that it's like close enough to to repeat.
Yep.
That's kind of the biggest issue probably, because aside from the wear issue, the way we structure most of our work, if everything was cut in place and only ever on one machine, it kind of wouldn't matter too much.
Totally.
Anyhow, yeah, it was like Ariel spent some hours on it, and then she was like, I can't get this right.
So this is sort of, I'm tying it back to the lean waste.
Yeah.
Sort of around, I mean, standardization is not a lean waste. It's more like 5S or 3S, sweep, sort, standardize.
Mm-hmm.
But, yeah, having it be able to move across many machines, you're probably reducing defects by getting it right.
Mm-hmm.
Ideally, hopefully.
Yeah. Also reducing over process or, over processing of like complicated setups, like making things plug and play.
Yeah. Waiting for one machine, like getting
Mm-hmm.
it to run across two machines would reduce waiting from the perspective of the parts, probably.
Yeah.
That's a tricky one. Yeah. I'm trying to think. I mean, it's very clearly useful.
Yeah.
And essential to make good parts.
Yeah.
So that is your business.
Yeah.
Nice. So we did, as I mentioned last week, a second set of paint racks. So they're very labor intensive to make.
Oh, interesting.
We need 16 of them, and each one holds 8 parts. So you're bending 16 times 8, which is like a bunch. 140 something. And so that took a while, but it sort of allows us to rack a new set of parts while one set of parts is in the oven curing.
Mm-hmm.
And so we can kind of get all the parts queued up. And so, well, in some ways, let's see.
I mean, that's reducing waiting.
Yeah, I think it's mostly reducing waiting. It was basically really hard to synchronize the whole shop, and if anything went awry, we would not be able to produce the number of parts we were hoping to produce that day.
You'd be down a whole batch, basically, and not able to fill it in.
Like even yesterday, which was the first time we ran with 2, I take the ferry back and forth, and I was aiming for the early ferry, but then my plans changed, which let me take the later ferry. If I had taken the earlier ferry, we would not have gotten that second batch done. Which is not why I changed my plans, but it's still worth noting. Like, it's still tight. It's still hard. And so there's improvements to be made there. But that was a big one. Just kind of... And what let us sort of see it was diagramming out the steps involved and the lead times involved in each step. Or sort of like how much time each process took. Mm-hmm. And then it was like, oh, like fitting 2 of those in a day, if it's all sequential, is really hard. And so having that second set of racks lets us just parallelize the work. So it's sort of actually thinking it through. This is sort of saying that the racks are maybe not a bottleneck, but that they don't have enough throughput per time, I guess, at peak, which is when we're doing a changeover of like parts, right? Taking the painted ones off and putting the new ones on. Yeah. And so we can either make that process faster, or we can buy a second piece of equipment. In this case, racks, or make a second piece of equipment. Right. That's pretty typical production stuff. I feel like
obviously thought of adding an oven, right?
That is next.
Yeah.
We're kind of like yesterday, we were like, all right, an oven is next, because it sits in the oven for 2 hours. Yeah. So if we could just, it would be huge.
Right. And you could do like one every hour and just.
Yeah. No. So that's definitely the next thing. Mm-hmm. I'm trying to figure out how we want to go on those ovens in looking toward a robot. I kind of want to think about all that together. Yeah. A tunnel oven would be sweet, but also probably enormous unless we build it, which
like a pizza oven, right? Like a flow through pizza oven.
Yeah, like a conveyor belt kind of in an oven. Yeah. Yeah.
Interesting. Part of our trunnion was adding a second part of this whole thing was adding a second dual pneumatic vise on our high torque machine. So in the past, when we'd wanted to use that system, we would end up, for the most part, running all op ones, batching, then running all op twos, with the aim of eventually switching to this system.
Very cool.
So now that we have two, we can do finished parts every cycle.
That's awesome.
And we're kind of staging this so that like we're going to get the workflow, including the cam side, the cam template side, really dialed. We'll just run any parts that fit in that envelope on those vises, just probably manually to start with, and then add gripper to the workflow at some point in the near future.
Very cool.
But that was very exciting, and so that's reducing waiting as well.
And overproduction of op one parts, I would say, because overproduction is the issue there. One issue with overproduction is defects.
Yeah.
And op one, op two work is
Right.
classic.
Yeah.
Like, oh, we didn't catch this until a finished part was done.
And overprocessing, I guess, because you're like extra handling, extra storage.
Yeah, and the big one here, and I'm not sure how to fit it into the lean waste, but I run op one and op two on one vise, and we've talked about this a lot. There is a lot of extra work that goes into trying to pack two ops into one set of jaws.
Yeah.
And so it seems ridiculous, but just breaking it out into two vices makes that process way easier.
Way simpler. Yeah.
We had questions when I put the flip station in place. We had a bunch of people, which thanks for sending it. For sure. Always fun to see new ideas. Showed videos of people using a spindle gripper to do the flip. And there's a few ways of doing it. And we've talked about a lot of them. And really what it came down to was like, it's so worthwhile to develop universal systems that don't take a lot of custom engineering per solution.
Yeah.
And so like doing those flips, yes, some parts are going to allow for it, but then you need to design your grippers to hold op one, op two, and be able to flip. And you have to design your vice jaws to have clearance for the flip and op one and op two gripping properly. Like it just starts to be a lot of requirements. And so you're sort of increasing your engineering time substantially on every part instead of doing a bunch of extra engineering and laying out a few extra $1,000 up front to just have a really universal, simple solution. So I have to say I am jealous of your two vices because there's also an inherent waste associated with packing two ops on one vise, which is the oversizing of your stock to allow for, it's not inherent necessarily, but it's often
Often.
Very cool. I'm excited to see that whole system running. I'm sure not as excited as you are to see that whole system
I'm ready. I'm really ready.
Sam added a shelf between our sandblasting cabinet and our gas out cabinet, in sort of in this mission to run two batches of paint in one day, because there was an issue of not having a place for our second batch in the day as it came out of the sandblasting cabinet. If there were parts that were going for the first batch in the oven, mixing them really doesn't make sense from a timing perspective. And then also sort of just makes it more confusing when you go to pull stuff out of the oven. What are you pulling out? So now there's just a little shelf that's a buffer essentially for that oven. Really nice improvement. He used a clamp and attached a little piece of wood to an existing
like a
bench
stud. Oh yeah.
And very quick. And the coolest part is definitely seeing sort of a noted increase in number of improvements that he's kind of been making around the shop. And it's really cool to see him kind of getting into that mindset of like noticing and then just making quick fixes. On that note, up in the paint department, I was showing him like how like when I mix paint, I have to turn around from where I'm mixing it to enter that info into the computer to tell me how much of part 2 to add to the paint. And I was like, it would be really nice if we set up another computer over here so I could just do it at this bench. And he's like, what if we just moved the scale next to this computer? It's like, brilliant. So that took all of 10 seconds and no money. So Yeah,
Like it.
very simple and super effective.
Cool. I bought 4 more Schunk manual vises, which was a little painful from a cost standpoint.
Okay.
And I initially was only going to buy 2 more. And then I was kind of like, if I'm doing this to reduce setup variability and have a universal cam template,
Yeah.
I need to have it be universal on all the machines.
Okay.
So I bought enough to have 2 on each machine if
Wow.
we need.
Nice.
And the thought is that we will never use any other vices unless they're just too big for what those will hold, which is, I think they hold up to 6 inches, basically.
So there will be a few, but
there'll be a
that's
handful of
probably
things.
80%.
Yeah, there'll be a handful of things we won't be able to use in them, but and there might be some situations where we'll have to decide whether we want to do op 1 batch, op 2 batch with longer parts.
Sure.
That just because we're going to have them on a trunnion, and so if we need to span 2 vices,
Right.
they're not dual station.
Yeah.
So we'll have to kind of make those decisions as they come, but I think that's following the whole 80-20 rule. That's a very small percentage of our work.
Right.
So either we'll just deal with it and do op 1, op 2 on those parts when we have to, or we'll pull the trunnion and put standard dual station vices on the table. But so anyway, the real improvement here is not so much that we bought the vices, that's that they are going to allow us to have hopefully basically 2 cam templates, where one for that vice type and one for the pneumatic vice type.
And maybe one for orienting them in Y and one for orienting them in X, or will that be built into one?
It'll be built into one. So I started working on this last night. Basically what it's all one template, and then you just pick a different origin.
Gotcha.
That's rotated around the center axis for how you want to orient the vise.
And you have a different one modeled in, or?
I mean, it's just an origin, so it's just like...
Oh, so it will move. The vice in the model moves when you
vice
do that?
stays the same. You just say, instead of this line being X, this line is Y. I don't know if that makes sense.
Sort of. I'm not understanding. Does the vice in the model shift?
No.
So you're not modeling for like collisions, or how are you?
There's with that one. I don't usually model the whole vise. I model the jaws.
Gotcha. Really? Even when doing 4th axis stuff.
I have just kind of like some rules of thumb.
Okay.
For how far you have to stick out to get to center line.
Gotcha.
And
that's probably a quicker way of doing it.
Yeah. Also, like the thing that's usually going to hit is the spindle casting, or something hanging off the spindle casting, and that is harder to model as part of the simulation.
I made all my own tool holders and sort of added this humongous cylinder on top of each one, which sort of represents the like spindle nose. I don't think it really gets into the beyond that, but yeah. Anyway.
Yeah, I thought about that. It didn't seem like it was maybe we will at some point.
Yeah.
Especially if we get into 5-axis work someday or something.
Totally.
But right for now.
And I think they've added machine simulation to Fusion.
Yeah.
I haven't messed with that, but I think that would let you sort of...
Yeah, in theory.
Put the actual...
For now, it's like I know the vise is, in this case, 160 millimeters wide. So I need to have... From the bottom of the V flange, need to have half that distance to get to center line.
Yep.
So it's
that
pretty
makes
straightforward.
Sense. I think in general, standardization, probably the biggest waste there is over processing, right?
Yeah.
Of sort of like needing to rebuild a model every time.
Yeah.
Because everything is new.
Yeah. As soon as I started going down this road, like it's the classic, like you can't unsee it once you've seen it.
Yeah.
And
with just how much time you're spending programming the same thing over and over and over.
Yeah. Just like, oh my God. So I didn't actually put this on the list, and I'm jumping ahead here, but started working on templating individual tool paths yesterday.
Oh, cool. Yeah.
In the past, I've just like copied and pasted whole programs that were like close enough and then edited.
Mm-hmm.
But the templating toolpath thing seems like it could be pretty useful to be able to just kind of like pick from a list as you need to, instead of like going through and deleting out and
remembering which program you did a thing in that was similar. Yeah. Very cool. So this was mostly around like we've had a bunch of defects on, not a bunch, but increasing defects on our 1-inch cams.
Mm-hmm.
And
wait,
now
increasing defects?
Yeah.
You were seeing an increase in defects.
Yes.
Gotcha. I thought you said you were increasing defects.
Oh, yes. We're working on increasing our defects.
I guess you were, technically.
Yeah. So we had fixed this problem on our 3/4 inch cams, which is basically when we place the stock with the gripper.
Yeah.
And I will say, we did not look for a root cause of why this is why our scrap rate is increasing. So that is definitely on my to-do list. But either way, this is a more robust system. Basically, now we place the block on the vise, the block of aluminum, and then we sort of come down with the gripper fingers and then feed to push the block into the right position before closing the vise. Because before we were sometimes having the block slightly off, and so the part wasn't coming out complete because it was, there wasn't aluminum enough to contain the part, kind of, if that makes any sense. So that should fix the problem. I fixed the programming to do that feed move, and then ran 2 or 3 of them and then left. So it ran for 4 hours last night, which was a big part that increasing our run times has been a big part of actually being able to double our production. Like now we can actually machine all the parts for 120 buckles per day. Yeah, I think. If we're diligent about keeping it up during the day. So
cool.
Yeah, so hopefully that fixes that scrap. And the really frustrating part there is when you have a defect, I mean, it's a bummer because it's wasted machine time, it's wasted materials. The real bummer is when it goes all the way through the system. I mean, the worst is when you ship it. Right, which I don't think we've shipped this defect because it's pretty visibly apparent, but it's definitely made it to our assembly area, or not to our assembly area, caught in QC. But that means we've already put a lot of time into painting it, into sandblasting it, like all this stuff. And then it's also one piece that we can't sell. So defects is one of the 8 lean wastes, and we were seeing them, so I think it should solve the problem. Cool.
Another part of our trunnion upgrade, so we did one on our S700, and then we made a slight variant for our R450.
Okay.
So that we can do 2 4th op parts on our R450.
Okay.
2 4th op operations, rather. We have a rotary on one pallet on that machine, not on the other. So prior we could do with a single station angle plate trunnion, we could do 1 4th op operation, and then on the other table or the other pallet we could do a second 3-axis op. So now we can put 2 vises on that trunnion if we want to, if we need to. Part of what we had to do, and something I wanted to do anyways, when they installed the machine, they installed the toolsetter just right on one of the T-slots, and they maxed it out in X out of the work envelope, at the edge of the work envelope, but in Y it was still quite a bit inside. So it's kind of in the way. And the trunnion was going to hit it when it rotated, so I had to move it. I wanted to move it, and then I had to move it.
Right.
So got it out of the envelope, and I in the process discovered that the envelope is actually physically larger than I knew the number, but when I'd looked at the table, there's it's made from a casting and the sides are rough. And in the center it kind of dips down, and that's rough and not machined. So there's a raised area that's machined with the T-slots and the table surface.
Interesting.
And I thought that the edges of the table, both where it falls off the edge and then where it goes, it's that center rough section was the edge of the envelope, but it actually goes another centimeter past, I think, or maybe more.
So do you put it on center line? out of the envelope?
I put it 50 thou inside in both directions, basically.
Yeah.
But yeah, it's pretty much maxed out.
Nice.
And wow, they really like take clearance to the extreme when the spindle's all the way towards the divider wall and all the way down. There's like 3/8 clearance between the divider wall and the spindle. It's like, it's quite impressive.
That is impressive.
Yeah.
Watching Joe over at Cobra Frame Building mess around with his new lathe. That, man, those sub-spindle turret lathes, they seem tricky to program.
Yeah, clearance is a real thing in lathes.
Yeah. And I haven't run one. I mean, I've run a manual.
Yeah, I've never run
really
that.
Count.
I've never run that type of like live tool y-axis lathe, and you could see it getting in trouble pretty.
Yeah,
easily.
it just seems like your gains in one place directly affect, negatively in the other. Like longer tools stick out to get to center line, then you're swinging around a longer thing.
Yeah,
when you move that over. Anyway,
this is a tangent, but I can see really strong arguments for having everything in one machine and not handling it and getting finished parts out of stock. I can also see really strong arguments for letting a lathe do what a lathe does and letting a mill do what a mill does and creating a cell. Mm-hmm. And I really don't have a good answer at this point for where we'll end up going in the long run.
Robot on a track.
I mean, maybe. Yeah. I don't know. It's kind of like, how versatile can you make a cell, basically?
Yeah.
And how automated can you make a cell? But it seems
while maintaining versatility, I think, is the key.
Yeah.
Yeah.
Versatility, like in theory, from the like programming and setup standpoint, programming and setting up to like a simple 2-axis lathe operation.
Yeah.
And a simple 3-axis mill operation is probably going to be more straightforward and simple and like repeatable than a complicated y-axis dual spindle operation.
Interesting. Yeah, I mean,
but it's this weird thing. Like I don't even know how you would start to spreadsheet it either on like breaking out where your wins and losses would be, because there's so many variables that I feel like there's a lot of what really matters at the end of the day you might not be able to predict or see.
I'll have to think about that.
Me too.
I don't know.
I think about it all the time.
Nice. Well, we are coming up on time here. We did one other that's worth mentioning is adding a webbing rack. Yeah. Because I asked Sam, we've been having issues with, we had 2 parts go out of stock. And so it's kind of like, what's going on? The answer is production leveling is important when you're using a Kanban system, I guess, which is why Toyota does it. And so I sort of was asking, like, why are we having spikes in production? And what it came down to is that we were running an order with a unique webbing style, and to run that, we only had enough webbing racks for our existing styles, and so we had to change one over. And just that, I mean, it takes like 2 minutes, but just doing that was much more tempting to batch. And so what was happening is we were doing a whole bunch of that big order and then doing a whole bunch of individual orders. The effect of that is that you bang through a lot of individual orders, and that ran a product out of stock. So we added another webbing rack, and so that reduces changeover time. So most temptation to batch is a result of high changeover time. Yeah. And so we basically eliminated that temptation. And so now we're going to get back to more level production where we can do like 10 of the big order and then 10 small orders, 10, that kind of thing.
Cool. Right on. Very last one for me is we started negotiating a lease on a new space.
Wow.
Yeah.
That's big.
It's exciting.
Very cool.
More on that later, assuming things progress in a positive direction.
Awesome.
But yeah, big stuff. That's
very cool.
So I think that wraps us up for the week. Thank you all for listening. We will see you in additional several days.
Yes.